So we were looking at this figure on recharge, discharge, and this phase space, or the mandala that Billy Kessler created, which created some excitement, but is hard to fit all the El Niños into this. But essentially, we focused on a big El Nino, which had a very nice pathway from recharge state and the La Nina state of 96, began to discharge and then evolved very systematically as a strong El Nino, and then it went back into the recharge state slowly, negative anomalies in Nino 3, so La Nina, and then discharge completed back to recharge. So you can follow up this figure from the paper from 2002. But essentially, the point I would add here is that when the El Nino is very strong, like the 2026 one that we are sitting and watching here, I'm recording this in June 2026, the evolution tends to be very systematic and clear. In fact, if the signature of El Nino is already present during this early in the summer, June, it's already very clear, then you don't even need predictions that El Nino is already here. It's going to grow to its mature phase by December, January, February. The question is, how strong will it get? Right? And that's where the prediction challenges are. And these are other events which you can see are hovering very close to the intersection of 0, here, and they are not evolving as systematically as the big one here. And this other one, 87 to 92, was discussed a lot because there were multiple small El Niños, and people said that was related to global warming impact on El Nino. Turned out to be not really the case, and so on. So this is very useful to say that the recharge discharge is a very solid paradigm, and it does work. And we took it further and argued that the system knows where to go by the time it gets into the spring of a given year. So January, February, March, April, May, it either wants to go into a La Nina or a normal year or an El Nino. So that's why we say when you make predictions here in the spring months, there is something called a spring predictability barrier, because the temperature gradient is flat, the system is very noisy, one little perturbation can send it in different ways, etc., etc. But how does the system know that it has to go here or here or here? And that was the idea of a discharge, and that the discharge actually starts very early on, and it starts as the meridional tilt of the thermocline, as we mentioned before. Very nice paper by Minan and McFadden shows that the discharge, the meridional shift starts much earlier, and it leads this zonal part in the deep tropics. So once the tilt is finished, then it begins to tilt zonally so that the warm waters flow from west to east, as we have seen here. And we'll come back again to this idea of having different flavors of El Nino, and we argued here in this paper from Ramesh and Nandini, Ramesh and myself, that even though El Nino surface expressions may be different, as we'll see, as we saw already a little bit, Central Pacific El Nino, canonical El Nino, and extreme El Nino, etc., the discharge and recharge processes are essentially the same, and to extract that specific detail, you have to take the climatology of that period. And there are nice papers showing that El Nino actually has a low frequency rectification. It redistributes in a way that if you have a few of them in a couple of decades, it actually changes the background state. You would expect that. So the climatology itself should depend on having more El Ninos, more La Ninas, or equally distributed, etc., etc. So if you take the climatology of that period, 1950 to 76, 77 to 2000, these are well-known regime shifts, and 2001 to 2007, which is the data that was used at the time, then you see that all of them have very similar behavior in terms of the propagation of the warm water anomaly from the west towards the east and surfacing in the east, and how strong the El Nino gets will depend on these anomalies. Some are very strong, some are not so strong, and then there is the coupled feedback, the Birknes feedback that we talked about. Plus, you have to remember that This starts more than a year before. If the 2026 El Nino is going to peak in December, January, February of 26-27, then this discharge that we are looking at right now it started in June, July, August of 2025. Okay, can that be used to make El Nino predictions better? I will come back to that a little bit later. So let's jump to the quickly to the El Nino theories. We already mentioned recharge discharge oscillator, which was proposed first by Fei Jin. He's been building on it and trying to connect also to the termination of the El Nino now, which I will mention briefly later. But basically his idea is that when you have a discharge going on, you have westerly wind anomalies here. We will use the word westerly wind bursts later on, but you can think of these as weakened trade winds as well. Trade winds are easterlies and westerly anomalies means weaker trade winds. So you have basically discharged warm water by so-called spheroid transport out of the deep tropics. Wind stress curl is going to give you spheroid transport, so you are exhausting the warm water, so you are deepening the thermocline in the east and shallowing it in the west, but the mean thermocline shifts up. You have exhausted the warm water and you have shallowed the entire system across the tropical Pacific Ocean. Then you are getting into stage 2, where the wind anomalies die away, the SST anomalies die away, El Nino is decayed, and then you have ended up with the thermocline anomaly that's shallower than the climatology. This is the climatology here. So that's shallower by the time you're done with an El Nino. Then you come into a stage where the recharge starts. So winds begin to pick up, trade winds begin to pick up. So cold anomalies begin to appear. You have positive feedbacks because SST gradient gets stronger, pressure gradient gets stronger, drives stronger winds, drives more upwelling, pull up the thermocline. There is the climatology, and if La Nina continues for a few years, there is the climatology of long-term thermocline depth, and you're going to end up with a deeper thermocline than you started with. Does this say exactly why the discharge starts? Not really. When you say recharge discharge oscillator, it means it's a stable oscillator, so it's going to keep doing this on its own. Then the question is to explain why the periods are not always constant, as we said before, right? So the other ideas have depended on adding waves to this whole process. This was one of the papers by Joel Picot way back in the 1990s, just after Fei Jin's paper appeared. Basically, it was focusing on westerlies again, that we mentioned already, and it produces a downwelling Kelvin wave, but westerly anomalies and westerly wind bursts are different. Wind bursts are something that happen something like 1 to 7 days. Let's say they are synoptic wind events which are going to force a wave. If you change the winds, then you can slowly shift the mean conditions, whereas if you have a burst of wind, it can trigger a wave. Downwelling Kelvin wave is going eastward. It's pushing the thermocline down, converging warmer water, so you end up with a warm pool of water below the surface. But it also generates an upwelling Rossby wave going the other way, which lifts the thermocline. So you are pushing the thermocline down in this direction, pulling it up in that direction. Colder SSTs, this reflects from the western boundary as an upwelling Kelvin wave, which is required to break the positive feedback we mentioned here. So this relies on waves bouncing around from both boundaries to give you the termination phase of this positive Birkness feedback that we talked about. So El Nino sets in place, and there are details even before it's finished. It already begins to move. So the peak will happen in December, January, February, but the subsurface processes are beginning to revert already in October, November of 2026 itself. Okay, the actual termination of the 26-27 El Nino may happen in March, April, May of 27, but the recharge phase slowly begins to build already. Trade winds begin to strengthen already, and so on. So you have year 1 and then year 2 and 3. So you have these waves bouncing around, and then there are details. Currents can shift the waves, Doppler shift, and so on. So you transition to a La Nina here. So this is relying on the wind generated waves to do the same thing. But all these are kind of diagnostic models, which means you look at past events and you try to fit models to them, waves or recharge discharge. This is the figure from the Wine and McFadden paper, which is looking at warm water volume, and the dashed line here, the solid line is the meridional tilt and the dashed line is the zonal tilt, and basically they argued that the meridional tilt leads the zonal tilt. So the meridional tilt and the discharge phase starts, and then it comes to the deep tropics in the western Pacific. Then it begins to move eastward, which is the zonal one we focus most on. Okay, there is other details that look also at the western Pacific oscillator. This was proposed by Chunzai Wong and I think Bob Weisberg, which basically relies on wind stress curl off the equator as well as the waves on the equator. Some details, again, remember that these are kind of diagnostics. When you have a model, a general circulation model, which is a global model, it's not putting any of these things in. It is doing, sun's energy is given, it has the atmosphere, land, ocean, maybe other details, and it has intrinsic El Nino inside it, and it produces El Ninos and La Ninas if you let it run for a while. But when you make predictions, you are going to initialize the ocean conditions, sometimes also the atmospheric ocean conditions together, and then you're going to integrate forward, and then the model says El Nino is coming. So all the predictions that have happened so far rely on such models or some simpler models like the Keynes-Ziebiak model or sometimes statistical models and so on. So these are what we diagnose from past observations, and you can take the models and do that as well. Joel Pico also mentioned the advective reflective oscillator, where the front between the warm pool, fresh warm pool, and the cold saline cold tongue moves back and forth. So it is situated just around dateline under normal conditions. The waves are running around again, downwelling Kelvin wave, downwelling Rossby wave, upwelling Rossby wave, reflecting into upwelling Kelvin wave, and you have to just see what they do to the thermocline on either side. So you can see that you have to remember Kelvin waves require either the equator as a dynamic boundary or the coasts as a real boundary. Okay, so you can see that El Nino and westerlies act together, as we'll see later, but before the El Nino peaks, the front begins to move back and then it begins to recharge. So there is recharge discharge happening as well as thermocline movements happening, wind anomalies happening, Bjerknes feedback happening, but multiple explanations can be given. And altogether, the Chunzai Wong has been writing a lot about these. He makes a unified oscillator, which is basically trying to say recharge, discharge, waves, off-equatorial generation of waves on this side, twin cyclones as he calls them, are all can be unified into one theory, and which term dominates depends on specific events. That's where this figure comes back to say that not all El Ninos have the same kind of cycle, that weaker El Ninos may have one term dominating, the stronger El Ninos may have another term dominating, and so on and so forth. Okay, I don't know how much more time I want to spend on this, but just remember that every time you have multiple theories, which means we don't have a consensus, so we don't know the exact answer, we fit different explanations to past observations, and idea is to collect more observations, build a theory, and confirm the theory with even more data. And right now each El Nino looks different, each El Nino has a different process dominating, waves are not always obvious, and this warm pool, cold tongue, etc. are not always moving in a systematic way. Recharge discharge is happening, weak, strong, etc. And we will talk about flavors of El Nino and return to this idea of whether recharge discharge are always happening the same way or not. This got a bit longer, but we are discussing multiple theories, so that's okay.